Every major financial bubble in history had a moment where the story and the reality quietly separated, where the headline said one thing and the underlying data said something else entirely. Tulip bulbs, dot-com stocks, mortgage securities. In each case, the people sounding the alarm were pointing at the wrong indicators. And by the time the right ones came into focus, the damage was already done. We may be in one of those moments right now, and a team at MIT just published research that explains exactly why, not by predicting when the AI bubble bursts, but by showing us something more unsettling. The map everyone is using to navigate this transition is measuring the wrong thing, and the exposure that map cannot see is 5 times larger than the one it can. Here is what most people understand about AI and the economy. Tech companies are cutting headcount. Junior developers cannot find work. Hiring freezes are spreading across the industry. And the anxiety about AI replacing jobs has become one of the loudest conversations in business media. None of that is wrong, but according to MIT, it is dangerously incomplete. The core insight from their research is this: AI does not replace jobs, it replaces tasks inside jobs. A lawyer does not disappear overnight, but the hours they spend reviewing routine contracts quietly shrink. A financial analyst keeps their title, but the time they spend processing documents and pulling data compresses. The job still exists, the wage bill still exists, but the underlying justification for that wage bill is eroding. This distinction sounds subtle. It is not. Because our entire economic infrastructure, GDP, unemployment figures, productivity data, workforce planning models, was built to count jobs and people. It was never designed to look inside a job and ask which parts of it AI can already technically perform. So the erosion does not show up in the numbers we track. By the time it does, the transition is already well underway. To fix this, MIT built something they call the iceberg index, and the name is deliberate. The visible tip is what everyone is already watching: the tech sector. When you measure the wage value of work inside tech jobs that AI can technically perform right now, it comes to about 2.2% of total U.S. labor market value, roughly $211 billion. That is the number generating all the headlines. That is the part above the water. But the capabilities driving that number, document processing, routine analysis, data handling, summarizing information, do not belong exclusively to tech. They show up across hundreds of occupations that have never appeared in a single headline about AI disruption. Financial analysts, HR coordinators, insurance processors, legal secretaries, administrative professionals across every industry in every state. When MIT ran the same methodology across the full economy, the number did not grow modestly. It jumped from 2.2% to 11.7% of total U.S. labor market wage value. That is roughly $1.2 trillion, 5 times larger than the number everyone has been focused on, and almost entirely invisible to the tools governments and companies are currently using to prepare for AI. How did they actually build this index? Because the methodology matters. MIT started by mapping 151 million American workers across 923 occupations and 3,000 counties. To define what each occupation actually requires, they used a U.S. Department of Labor database called ONET, which breaks hundreds of jobs down into their specific component skills, things like analyzing data, processing documents, coordinating with others, critical thinking, interacting with computers. Each skill comes with an importance rating and a difficulty level built from surveys of real workers doing those jobs. Then they did the same thing for AI, cataloging over 13,000 production-ready AI tools currently being deployed inside real companies. And they put every single one of those tools through the same ONET framework. The result is 2 maps in the same language. For the first time, you can make a genuine apples-to-apples comparison between what human workers do and what AI systems can technically do right now. The key design choice was weighting by wage value rather than job count. Because automating 60% of someone's time does not mean automating 60% of their economic value. The tasks AI handles might be the lower value ones, or they might not be. The index forces that question to be answered honestly, occupation by occupation. If this kind of analysis on where the economy is actually headed is what you come here for, subscribe now. We break down the research that actually matters for business and investment every week, and there is more coming. So what does the map actually show, and who is sitting on the fault line? The answer is not who most people expect. The most exposed workers, according to a separate Anthropic study tracking real AI usage in professional settings, earn 47% more on average than the least exposed group, are nearly 4 times as likely to hold a graduate degree, and are 16 percentage points more likely to be female. These are not factory workers. These are the people who did everything society told them to do, got the degree, got the professional job, built a career around cognitive work, and are now discovering that cognitive work is exactly what AI is best at. The geographic picture is equally counterintuitive. If you had to guess which states carry the highest AI exposure, you would probably say California, New York, Washington. You would be wrong. South Dakota, North Carolina, and Utah show higher exposure values than California or Virginia. Tennessee is the starkest example. Its tech sector exposure is 1.3%, nothing that would register in any workforce planning model. But its overall iceberg index is 11.6%. The white-collar workforce keeping Tennessee's economy running is 10 times more exposed than the tech sector anyone has been watching. These are states that have spent years preparing for robots on factory floors. The white-collar disruption is arriving first, and nobody built a plan for it. Now, here is where the bubble framing becomes important, because this is not just a labor story, it is a valuation story. The AI investment boom is built on a premise that AI productivity gains will be large, broad, and will translate into earnings growth across the companies deploying these tools. Trillions of dollars in market capitalization have been added to companies on that basis. But if the iceberg index is right, the exposure that justifies those valuations is concentrated in exactly the occupations and industries where the gap between what AI can technically do and what it is actually doing in practice is still enormous. For computer and math workers, AI is theoretically capable of handling around 94% of their tasks. In observed professional use, it is currently doing about 33%. Legal work, architecture, financial analysis, the same pattern holds everywhere. The capability exists. The deployment does not yet match it. And the gap is being held open by regulation, integration friction, and the basic organizational requirement that a human still checks AI's work. That gap is what the market is betting will close, and it may well close. But the tools investors, governments, and companies are using to track whether it is closing, standard employment data, GDP, wage figures, were designed for a different economy. They cannot see 95% of the risk they are supposed to be measuring. That is the condition under which bubbles form, capital flowing toward a story that the available instruments cannot actually verify. There is one more piece of this that rarely gets discussed, and it matters for anyone thinking about the longer arc here. About 30% of the workforce has essentially zero AI exposure. Cooks, mechanics, plumbers, nurses, childcare workers, people doing physical, relational, hands-on work that no language model can replicate. The assumption is that these workers are safe. Structurally, that is true. But safe from AI disruption does not mean safe from the consequences of AI disruption happening everywhere around them. Economists call it Baumol's cost disease. When productivity surges in one part of the economy, wages rise across the whole economy, including in sectors where output cannot scale. A nurse still needs the same time per patient. A plumber still needs to physically be there. Their productivity does not improve, but the wages they need to attract talent keep rising alongside everyone else's. So the cost of the services they provide keeps climbing. Healthcare, education, skilled trades, elder care, exactly the services that governments fund and that societies cannot function without. If AI dramatically accelerates productivity in cognitive work, Baumol's effect accelerates with it. The things AI cannot touch become more expensive faster. And the fiscal pressure lands hardest on the services people need most. The iceberg index does not predict when any of this resolves. It is not a forecast, it is a map, the most accurate map anyone has built of where AI capabilities and human labor currently overlap, weighted by economic value. And what it shows is that the conversation happening in boardrooms, in government policy offices, and in financial markets is being driven by instruments that can see roughly one-fifth of the actual picture. The other four-fifths is underwater, and capital is pricing the visible tip as if it were the whole iceberg. That is not a prediction of collapse. It is a description of misalignment. And in financial history, persistent misalignment between story and data has a reasonably consistent track record of resolving itself in ways nobody planned for. Thanks for watching. If this changed how you are thinking about AI and where the real economic exposure actually sits, subscribe so you do not miss what comes next.